Stop picturing some GPT living in the cloud. Imagine instead a powerful AI model right there inside your iPhone, iPad, Mac, or Vision Pro, able to understand you, generate content, and take action with full privacy. That's Apple's foundation models framework. And today, we're tearing the cover off what makes it tick. Let's dive deeper into the details and explore this. First, a new chapter in on-device AI. When Apple introduced the Foundation Models framework at WWDC 2025, it wasn't another half-baked SDK for cloud APIs. It was a declaration: we're bringing generative AI on-device, end-to-end, with performance, privacy, and simplicity you've never seen. At the heart of this framework lives a 3 billion parameter large language model. Small by today's trillion parameter standards, yes, but meticulously optimized for Apple silicon. This is no generic oracle. It's a specialized text engine designed to run offline on a single chip without ever pinging a server. So, when you ask for a flight itinerary suggestion or generate playful in-game dialogue, your data stays in the secure enclave. No data leaves your device. No cloud logs. Just pure, private intelligence. Second, the model that does what matters. Big LLMs can do everything if you have the hardware, the network, and privacy trade-offs. Apple's 3 billion parameter model does only what you actually need in most apps: content generation, write a polite email reply, spin up a short story, or craft a game dialogue. Text summarization, crunch meeting notes, or long articles into crisp bullets. User input analysis, classify sentiment, extract names and dates, or tag keywords. This isn't a general knowledge oracle. It won't debate quantum physics or recite the latest headlines. It shines at modular tasks, so you and your app stay in control. Pro tip: break complex features into small, targeted calls. Feed the model a snippet of text, get back a summary. Then feed that summary to another call for classification. That pipeline approach keeps each step reliable, fast, and accurate. Next, guided generation, making output bulletproof. One of Foundation Models' crown jewels is guided generation. Ask any LLM to output JSON, and you'll learn about hallucinations, missing commas, or phantom fields. Your parser is left to fend off malformed text. Apple solves this with constrained decoding. You define a schema, a grammar describing exactly what you need, and the model is forbidden from straying. At each token, it sees only valid next options. The result? Always valid, parsable data you can drop straight into your Swift structs. Why it's a game changer? Reliability. No more unexpected token errors. Simplicity. Your prompt focuses on content, not format. Speed. Smaller search space means faster inference. Think of it as code autocomplete for AI, but smarter. It never lets you write invalid code. 4. The Generable API. From types to blueprints. All of this magic hooks up to your Swift types via the @generable macro. Apply it to any struct or enum, and at compile time the macro as follows: inspects your type's properties and nested types, generates a formal schema, a precise blueprint, produces the constrained decoding logic and parsing glue. When you call the API to generate a trip, you get a native Swift object, not JSON text, not a dictionary. You can add a guide to hint to properties. The model then knows your name isn't just any text, it's a person's full name. This semantic context boosts accuracy without stuffing your prompt with instructions. 5. Snapshot streaming. UX that feels alive. We've all grown to love streaming chat text appears token by token. But that doesn't work for structured data. You can't render half a JSON object in your UI. Enter snapshot streaming. Instead of tokens, the API streams partial but valid objects. First snapshot, then the next, and finally, the full object. Bind this to Swift UI and watch your UI animate in each property as it arrives. It's like watching a painter layer in colors, fluid, engaging, and utterly modern. 6. Tool calling. Giving AI senses and hands. A fundamental limit of LLMs is their isolation from real-time data. They know only their training. But your app does know the current weather, your calendar events, your photo library. Tool calling bridges that gap. You register tools' Swift functions with names, parameters, and descriptions. When the model needs fresh data, it emits a tool call instead of a final answer. For example, model outputs for tool, get weather for city, Cupertino. Framework intercepts, runs your get weather for city function locally. Injects the result back into the model's context model and responds. It's sunny and 72 degrees Fahrenheit in Cupertino. All on device, all private. Now your AI can truly interact with the real world. 7. Stateful sessions and instruction hierarchy. For dialogues, foundation models provide stateful sessions. The model retains a transcript. Crucially, Apple enforces an instruction over prompt hierarchy. Instructions like developer-defined policies be formal. Never reveal personal data, and prompts like user inputs tell me a joke. This stops malicious prompt injections. No matter what users say, your instructions hold sway. It's a security anchor for conversational AI. 8. The pillars at a glance. Let's recap the 4 conceptual pillars. On-device model. 3 billion parameters, optimized for privacy and efficiency. Guided generation. Guaranteed structured output via constrained decoding. Snapshot streaming. Partial object streams that drive smooth, declarative UIs. Tool calling and stateful sessions. Real-world context plus secure instruction hierarchy. Combined, these form a developer-friendly ecosystem for building intelligent app features without ever touching a server. 9. Why it matters for you. You might ask, why go through all this complexity? Why not just call an existing cloud LLM? Privacy. No user data leaves the device. Latency. Instant, offline inference. Cost. No API usage fees. Reliability. No network outages or rate limits. Apple isn't selling you AI. They're giving you a platform, a fully integrated end-to-end solution that scales from quick UI features to advanced, private, on-device intelligence. 10. Building the future. Ready to dive in? Here's how to get started. Install Xcode 16.5 Beta. It includes the foundation model's APIs. Create a Swift struct and tag it at generable. Call foundationmodels.generate. Hook up snapshot streaming to a Swift UI view. Register a simple tool, function, and test tool calling in your app. Apple's developer documentation is already filled with examples, best practices, and sample projects. Within hours, you can transform a static form into a dynamic, AI-driven experience. This is a vision for tomorrow. Foundation Models isn't just a flashy WWDC demo. It's Apple's vision for mainstream AI, private, performant, and truly ubiquitous. As devices get more powerful, expect this framework to expand. Larger on-device models, tighter Swift integration, tighter metal acceleration, and even richer snapshot and tool calling capabilities. Imagine AI features that learn your preferences over time, offline, without telemetry. Or immersive Vision Pro experiences where objects in your room adapt to your voice. All built with the same primitives we've discussed. Apple didn't just give us an AI feature. They built a foundation. One we can stand on to create the next generation of intelligent, private, and delightful apps. So, go forth, add generable your types, stream those snapshots, and let's see what you will build. So that was the Byte Chronicles episode on Apple's Foundation Models framework. Thanks for watching. Please do share your thoughts on this AI revolution. We will be back with the next one, and until then, keep biting and keep igniting the code storm.